Good evening, students. The other day we discussed the general characters of fungi, classification, asexual reproduction and sexual reproduction. Now let us study a type study of Rhizopus, is a common fungus. When studying any form, you have to see the systematic position. Actually, what is the position of this fungi in this group division Mycota and class Zygomycetes, order Mucorales, family Mucoraceae. This is the systematic position of the fungus Rhizopus. Regarding the habit, it is a saprophytic fungus and it grows on dead organic matter. It leaves moist bread and other foodstuffs and jellies and pickles, and they produce a white web-like mycelium. So, in all foodstuffs, generally, if you keep bread in a particular way, it pays, there you can find after 1 or 2 days, there you can find a white thread-like structures are found, but you cannot notice at this stage. When they form into spores, black color only you can notice, that is Rhizopus. Next, you have to see the vegetative structure is a white cotton-like mycelium, which is cenocytic, that is aseptate multinucleate mycelium. This is aseptate, remember, and cenocytic, C-O-E-N-O, cenocytic, and profusely branched. The mycelium is differentiated into 3 kinds of hyphae. I already told the thallus of fungi is known as mycelium. The mycelium is made up of thin, fine, filamentous-like structure. Those are called hyphae. Vegetative structure, so 3 kinds of hyphae. There, number 1, that is, you can find here it is a substratum. In this substratum, it produces a rhizoid-like structures to absorb food material. Those are repeatedly branched hyphae which penetrate the substratum and absorb water and nourishment from this substratum. And then on the surface you can find, having a long internodes. I will show the diagram. Long internodes they have, these are called stolons. So these stolon, in the lower side it has these rhizoid-like structures, and upper side you can have these sporangiospores. Unbranched sporangiospores will develop from the upper side. So here you can find the diagram. There you can find 3 types of hyphae. The lower side on the substratum you can find a rhizoid-like structure, these rhizoids, and on this you can find these are stolons having long internodes, and in the lower side you can find the rhizoids, and in upper side you can find a tuft of or a cluster of sporangiophores are found, and at the end of the sporangiophore you have a globosporangium is found. So as told already, the hyphae is aseptate, branched, cenocytic, and cell wall is made up of chitin, and the reserve food material in the form of glycogen and oil drops. Regarding the reproduction, it reproduces by vegetative, asexual and sexual methods. The vegetative reproduction, this is quite common by the fragmentation. So accidentally it breaks into pieces, and each piece or each fragment is capable of develop into a mycelium after finding a suitable substratum. If a particular substratum, a suitable substratum is there, these pieces will develop into new mycelia. So generally the vegetative reproduction by fragmentation. And sometimes what happens, this is the second one, asexual reproduction. Asexual reproduction by aplanospores, that is non-moving spores or non-motile spores. So it takes place by the formation of aplanospores, and asexual reproduction takes place during favorable conditions. Generally, vegetative reproduction And asexual reproduction, when the conditions are favorable and it has a luxuriant growth, it wants to develop its generation or species, so the asexual reproduction takes place. When the conditions are not favorable, the place where it is lived is going to desiccate. It produces sexual development, and where the sexual spores are very heavy and having a thick wall, and so that they can tide over the unfavorable conditions. So here the aplanospore development, you can see asexual reproduction takes place during the favorable conditions. The multinucleate non-motile spores are called the aplanospores. So the other day, this I told the same regarding this. In the substratum, I told the stolons are there, and below the substratum you can have the development of rhizoids, and upper we have the cluster of these sporangia. So when this tip of the sporangiophore, 4 means stalk, tip of the sporangiophore becomes swollen, the nuclei and cytoplasm enter into this swollen this sporangial part, and then in the center place we have a vacuolated, and the remaining side you can find this cytoplasm and the nuclei are there. They are cleaved, break into pieces, each piece having some 2 to many nuclei, and have a cell wall around it and form aplanospore. This dome-like structure, that is called the columella. This columella helps in the liberation of the spores. So I told you this is in well time. The cytoplasm divides into many small 2 to 10 nucleated portions. Each portion becomes round, secretes a wall, and form into aplanospores. When the spores mature, columella swells up by absorbing water, and as a result, the sporangium bursts and liberate the spores. The spores, on germination, giving to new mycelia. So this is the thing I told you here. This is the formation of the tip of the sporangiophore. A rounded vesicle-like structure develops, and a nuclei and also cytoplasm enter into it. And here you can find a vacuolated space is formed, and here you can have the nuclei and cytoplasm. Later they break into pieces and form into aplanospores. Here you can find the columella in the center. After swelling this columella, a breaking of the wall takes place and spores are liberated out. So this is the formation of aplanospores in the sporangiophore. So another way of this asexual reproduction by the chlamydospores. The other day I told you already, the chlamydospores are thick-walled spores. During unfavorable conditions, the mature mycelium becomes septate. Actually it is a septate mycelium, but during the formation of chlamydospores, septa is formed and the protoplast of each cell rounded a thick wall around it. These are known as chlamydospores. These perinnate bodies, so that they can tide over the unfavorable conditions. Perinnation, so tide over the unfavorable conditions. After when the conditions are favorable, they germinate and form into new mycelia. So these are chlamydospores. You can see a bigger image. A chlamydospore, the cell into break and round up into a chlamydospore. So after finding some rest, it will germinate into new mycelium. Regarding the sexual reproduction, it occurs by the conjugation of 2 gametangia, occurs by the commutation of some gap, by the conjugation of 2 gametangia. So most of the species of Rhizopus are heterothallic. Heterothallic means the male and female structures develop on different thalli. So here we cannot separate the male into, you cannot find male and female structures, and we can call them as strains, plus and minus strains. They develop from different species. And regarding the heterothallic example, Rhizopus stolonifer, and a few species are homothallic, example Rhizopus sexualis, where the fusing gametes or fusing gametangia may be from the same thallus or same type of species. So in this, during this sexual reproduction, 2 hyphae of the opposite strains, that is plus and minus, come nearer. So two strains come nearer, or two mycelia come nearer. Outgrowths develop in the opposite strains. Outgrowths develop in the opposite strains and then come together. A division occurs in this. This is called a progametangium. A division occurs in the progametangium, and the terminal one is called a gametangium, and the basal cell is known as the suspensor. So then the septa is laid down at the distal end of the progametangium. The terminal swollen part is known as gametangium, and its basal part is known as the suspensor. And then when they mature, the wall between these two gametangia dissolves, and the protoplast and nuclei of opposite gametangia fuse and form zygospore. This is zygospore, and when two nuclei or two haploid nuclei are fused together to form a diploid multinucleate, zygospore is formed. The resultant zygospore enlarges and it develops a dark, thick, warty wall. So at that time only you can see that it becomes black color. It undergoes a period of dormancy, that is a period of rest it will take. So here you have this two, as I told you already, two mycelia come together and form a progametangium. This is one is called a plus strain, another may be a minus strain. So they come together, and then a division occurs here, and the terminal cell is called gametangium and the basal cell is called the suspensor. And then two gametangia of the opposite strains unite together, fusion of the cells takes place, and formation of the zygospore. Zygospore is formed, a diploid zygospore. And the germination of the zygospore takes some rest and germinates when the conditions are favorable, and all the diploid nuclei here, they undergo meiosis and form haploid nuclei. And thus there is the formation of zygosporangium. Zygosporangiophore will develop, and at the end, just like asexual reproduction, here also this a swelling of the tip takes place, zygosporangium, and the nuclei and cytoplasm enter into this zygosporangium through this zygophore, and there also breakage takes place, and each bit consists of some 2 to 10 cells, and after maturation, breaking of the wall takes place and release out, and they will develop into new rhizomous mycelia. So it grows erect to form a sporangiophore, generally called as a germosporangiophore. The sporangiophore bears a terminal sporangium, also known as germosporangium or zygosporangium, with a number of spores. So after liberation, each spore germinates and gives rhizopus mycelium. So here you can find this zygospore that is formed here by the fusion of two gametangia, zygospore. This zygospore germinate and give zygosporangium. Inside the zygosporangium, you can have many zygospores. So after liberation, they develop into new rhizopus filaments. So that is about the life cycle of rhizopus, the common fungus. There also the life cycle is haplontic life cycle, that is the dominant phase is haploid and the diploid stage is restricted to the zygospore only. Again, after undergoes meiosis, they form into haploid spores. So this is in a haplontic life cycle. Okay, next we have a study on these lichens. I think so far you might have known what is a lichen, but you may not know the detailed study of these lichens. Now you can study the detailed study of these lichens. This lichen, the word is coined by Theophrastus, 300 BC. He coined the word lichen. It is the association, a permanent association of a fungus and alga, which live in close association and appear to be a single organism. So algae and fungi live together as a single organism, that is called a lichen organism. Now let us see what is the association of these algae and fungi. So the fungal member is known as mycobiont and the algal member is known as phycobiont, or photobiont. So total, that is say symbionts. Both are symbionts. The fungal one, the fungal partner mycobiont, and algal member known as phycobiont or photobiont. So here the association, the algal members, with the help of sunlight, they prepare food materials and supply to the fungi, and fungi gives protection and also supply the water and minerals to the algae. So this is type of association we will discuss later. So majority of the phycobionts are the members of Cyanophyceae. 90% of this lichen association, the phycobiont is a Cyanophycean algae, and few members of Chlorophyceae and very few members of Phaeophyceae members. Regarding the fungal component, the majority of the mycobionts are, sorry, you correct it. So majority of these mycobionts are Ascomycetes or Basidiomycetes or Deuteromycetes. The study of lichen is called lichenology. Study of lichen is called lichenology. So let us discuss this lichen association. In this association, algal component synthesizes the food and supply to the fungal component. In turn, the fungal component supplies water and mineral nutrients and also gives protection. Some lichenologists consider this association as symbiosis, just like DeBerry 1979, and Reinke 1872 gave the term consortium. Consortium, it is a mutual growth and interdependence of each other. They used to depend each other. But Crombie called this association as master and slave association. Master and slave association, and in the Smith also called it as a helotism. Helotism, that is master and slave association, because the fungal filaments are arrested at the center and surrounded by the fungal hyphae, so that the fungal hyphae just controlling the algal cells. Algal cells have no freedom, so that it may be the master and slave association, and this helotism is the appropriate name given to these lichens. So everybody is willing to know that it is this association is known as helotism. Let us see where you can find these lichens. They occur a variety of habits like rocks, bark of trees, leaves, decaying wood, and Arctic to Antarctic regions. On the basis of the habit of lichens, they are classified into the following types. So on the basis of habit, the lichens are classified into the following types. The first one, they are called Saxicolous fungi, that's lichens. Saxicolous lichen, that is found on rocks. So example, Dermatocarpus corina. These are the examples for this Saxicolous. The second one, that is Corticoles. Corticoles means it is the lichens found on the bark of trees. For example, Usnea and Parmelia. Here you can have Parmelia. So there, these lichens grow on bark. Next, lichens, these are called terricoles. That is on soil or land, terrestrial, like terricoles or terricolous. So there you can find on the barren land or barren soil, you can find these lichens. Example, Cladonia and Lesidia. Cladonia and Lesidia. And these are called lignicolous. Lignicolous lichens. Lignicolous anaga, that is called grow on wood. Lignicolous grow on wood or on branches or tree trunks etc. You can find these lichen. This is Colicicum and Chinotheca. So this is a lignicolous lichen. Next, marine. Marine you can find on the seashore. You can find the sites along this point. You can find a number of lichens you can find on the seashore. There is Verrucaria and Caloplacentum. Caloplacentum. These are the lichens you can find in marine. Marine means on the shores of the sea. And regarding the habit, the next one, there is a freshwater. We can find hard siliceous rocks in the freshwater. Near the rocks, or near the rocks and freshwater, you can find Hymenalia and A.V.V.S. These are freshwater forms. So another classification you can find based on the thallus structure. This Hawksworth and Hill recognized 5 categories. They may be crustose, foliose, fruticose, leprose and filamentous. So these are the 5 types recognized by Hawksworth and Hill 1984. So the first one is a crustose type. Crust means patch. So the thallus is very closely attached to the substratum and provided a crust-like appearance. So on the barren rocks or wet and pavy, you can find a patches of crustose hyphae. You can find example Graphis and Dimirella. Here you can find this is a crustose lichen, a crust-like or patch-like thing. You can find crustose lichen. The second one, foliose. Foliose means leaf-like. This thallus is flat, leaf-like, well-branched, lobed, and attached to the substratum with the help of rhizoid-like structures. These are called rhizines. So in lichens generally, the rhizoid-like structures are called rhizines formed by mycelia. So these are foliose, the leaf-like. This is Collima and Parmelia. Collima and Parmelia. You can see the next slide. This is the foliose lichen. This is just like leaf-like structures are found. Delicate and thin leaf-like structures. This is foliose lichen. Next, fruticose lichen. The thallus is well branched, cylindrical, ribbon-like with a shrubby appearance, looking like a small plant, normal plant. So it is well branched, cylindrical, or ribbon-like with a shrubby appearance. They may be erect. They may be erect, Cladonia, Avernia, or they may be pendulous, hanging. Example, Asnia. These plants attach to the substratum by a disc-like structure made up of the densely packed hyphae. Densely packed hyphae. As I told you already, the majority of the plant body here you can find with the fungus only. Very small plant cell, only small or limited these algal cells. So here the rhizines also made up of these fungal hyphae, and also this disc-like structure or densely for attachment purpose is also made by the fungal hyphae. So here you can find this is a pendulous hanging from a branch, just like Asnia. This is called example Asnia. It is a branched, and whereas here it is erect one. This is called Cladonia. Next, classification based on the thallus structure. The fourth one is leprose type. It is very simple type and enveloped by either single or small cluster of algal cells. They are supported by a number of fungal hyphae. They grow superficially over the substratum, providing a powdery-like substance. A little brown powder-like substance is found, that is little cells of algae surrounded by the fungus. Example, Lepraria. So these are Lepraria, small patches-like structures on the substratum, powder-like structures, Lepraria lichen. Next, based on this structure, another one or the last one, that is called the filamentous type. So in this, phycobiont is filamentous, well developed and is covered by only few fungal hyphae. Here the thing is, the phycobiont is filamentous and covered by a little amount of fungal hyphae. So Rhacodium and Cynogonium are the examples of these filamentous lichens. Rhacodium, the same here you can find this filamentous by here, Rhacodium, and Cynogonium. This is another lichen that is a filamentous type. If you see very clearly, you can find some small filament-like structures are associated here. Regarding the fungal partner, so the first classification depend upon the thallus, and second one you can have this thallus structure, and here fungal partner. So Miller 1984 classified lichens based on their fungal partners into two classes. They are ascolichens and basidiolichens. In ascolichen, the ascolichen, the fungal partner is an Ascomystis fungus, whereas in basidiolichens, the fungal partner is a Basidiomystis fungus. So in this first class, ascolichens, as I told you already, in this the fungal component is a member of Ascomystis. It is further divided into two types based on the nature of the fruit body. So in sexual reproduction, they produce the fruit bodies. So based on this, there are again two types. Those are called gymnocarpae and pyrenocarpae. So see, in the Ascomycetes and Basidiomycetes, you know the fruiting bodies are there. In this Ascomycetes, they depend upon the fruiting body. There are two types, gymnocarpae and pyrenocarpae. In gymnocarpae, the fruiting body is an apothecium, just like as a bowl-like structure. This is example Parmelia. Here you can find this purely with this fungal hyphae there, and it produces the asci and ascospores, etc. And they will be removed, there is a released out, and find a suitable algae. Again they form into a lichen association. This is a fungal spore. It is distributed or dispersed and find a suitable substratum. It will develop into a fungal hyphae, and after finding a suitable algal cells, it will form into a lichen. The next one, this is pyrenocarpae. Pyrenocarpae, where the fruiting body is perithecium. Example, dermatocarpon. This is a perithecium, just like a flask-like structure with a small opening at the top, and here also you can find a number of asci and ascospores. Each asci consists of 8 ascospores. After after maturing, they are removed out and grow into a particular is Ascomystis fungus. The second class, this is Basidiolichens, where the fungal partner is a Basidiomystis fungus. Here example, Cora, Corella and Dictonema. So here you can find in the diagram, you can find this is Cora, and it produces a basidiocarp. It looks like a basidiocarp, and it produces by this Cora Basidiolichens. So the third classification, the first classification based on the thallus, second classification based on the fungal partner, the third classification based on the anatomy of the thallus or internal structure of the thallus. So based on this lichens are divided into two types. The one is called homoiomerous. So where algal and fungal partners are uniformly distributed throughout the lichen thallus. So in the lichen thallus, the diagram is given here, where you can find the rounded structures are algae and the filamentous structures are fungi, and they are uniformly mixed. Thus this type, example, Polyma and Leptogeum. The next, another type, that is called heteromerous. In this heteromerous, where algal and fungal partners are distributed into different zones, an algal zone and a fungal zone like that separately, not an intermixing as was seen earlier. So they arranged as upper cortex, algal zone, medulla and lower cortex. This type is most common example for milia. So this is the internal structure where you can find the upper cortex made up of fungal hyphae. There you can find an algal zone. There you can find algae only. The medulla made up of fungal partners and lower cortex made up of fungus. So majority of the fungus, only little part you can have algal, but they are separated into different zones. And some fungal hyphae are formed into rhizoid-like structures. So these are called rhizines. So now let us see some special structures associated with the lichen thallus. Special structures. Those are breathing pores. The name itself indicating they are for breathing purpose. There is exchange of gases. So loosely arranged areas found on the upper cortex part, upper cortex or breathing pores, they help in gaseous exchange. The second one, cyphellae. So these are also loosely arranged areas found in the lower cortex and they are circular depressions and they facilitate gaseous exchange. For example is given here, stricta, that you can see the depressions are loosely arranged cells in the lower cortex, lower side of the thallus. So here you can find this is the internal structure of the thallus, you know, and where you can find algal zone, you can have a medulla made up of fungal hyphae and the lower cortex part, and here you can find the loosely arranged cells, some gaps are there, facilitate gaseous exchange. These are called cyphella, cyphella, singular, cyphellae, plural. The next special structure, cephaloidea, cephaloidea. So here some lichens have two phycobionts. This is very interesting to note. Generally in each lichen a algal component and a fungal component, but whereas here there are two algal components of which one is a blue-green algae and the other is a green algae. Such lichens have three-membered association. Three-membered association, then the two algae and one fungi, this association. In such lichens, the blue-green algae is segregated as a special external or internal swellings. On the thallus, you can find an external swelling, sometimes internal swelling. There you can find, and some algal cells are surrounded by fungal cells are formed. So petigira, and this may be removed and it will develop into a new type of lichen. That is another lichen. The next one, a special structure is called isidia. These are elongated outgrowths on the appear on the upper cortex. These also you can find on the upper cortex, and some algae and some fungal partners are formed as a lichen thallus, the called isidia. They are erect on the surface, and they may be removed and develop into new lichen. Example, Formilia and Usnea. So regarding this reproduction, we will continue the reproduction tomorrow. So these things you learned, this classification of fungus, this classification of these lichens and also the special structures that you can find in this lichen. Thank you.